Yo, what's up? Yeah, 9G. You already know what it is. Yeah, come on, come on. Getting closer and closer, innit? Alright, cool. Saying that. Question 1A, yeah. So we've got x equal to 2y, 2t actually. Yeah. And then we got y is equal to t squared minus 3t plus 2, yeah. So you need to differentiate both of these here. So differentiate x here, we get dx over dt. That's going to be 2. And then you want to differentiate y as well. So the dy over dt is going to be 2 t minus 3, yeah. Alright, save. Now to find dy over dx here, with parametric equations, what you do here is you put the second one over the first one, so y over x here. So dy over dt, I'm not gonna write every time, but dy over dt over dx over dt, yeah. So basically that will cancel, you get dy over dx here. So basically you put the y1 over the x one here, so 2t minus 3 over 2. And so I can simplify that. 2t divided by 2 is gonna be t, and then minus 3 over 2 is minus 3 over 2, yeah. Alright, save. Question B. So we've got x equal to 3t squared here. Got y is equal to 2t cubed. So find dx. So dx is going to be 6t. dy is going to be 6t squared here. And so we're going to do the y over the t to find dy over dx. So dy over dx is going to be dy over dx here. So 6t squared over 6t. Obviously 6 cancels, you get t here. Alright, come. Alright, part C. X equal to t plus 3t squared here. Y is equal to 4t. So we've got dx over dt, yeah, that's going to be 1 plus 6t. And then dy is going to be 4, yeah. So therefore, dy over dx is going to be 4 over 1 plus 6t, yeah. Alright, come. Alright, d. So x is equal to t squared, yeah, minus 2. And y is equal to 3t to the power 5, yeah. So again, so dx here is going to be what, bro? Dx over dt is going to be, bring the 2 down, so we got 2t, yeah? And then dy over dx, dy over dt is going to be 15t to the power 4, yeah? And now, fam, obviously now put dy over dx here, so dy over dx is going to be dy over dt divided by dx over dt. So that's going to be 15 over 2 t3, yeah? Come. Yeah, because t to power 4 over t is going to be t3, yeah? Alright, safe. E. X is going to be equal to 2 over t, yeah, which I can write as 2t to the power of negative 1, yeah, because if you have something over t, it becomes t to the power of negative 1, yeah. Alright, calm. Then we got dx over dt, yeah. That's going to be, bring the negative 1 down, that's going to be negative 2t to the power of negative 2, yeah. And then same situation here with the y, yeah, we got what, bro? We got 3t squared, yeah, minus 2, yeah. So to differentiate that, dy over dt is going to be, bring the 2 down, that's 6t, and then that goes away anyway, it doesn't matter, bro. So now we can find dy over dx here. Dy over dx is going to be dy over dt over dx, yeah, naturally, bro, naturally, yeah. So that's going to be that divided by minus 2 t minus 2. So this is like power of 1. So 1 minus minus 2 is going to be 3. So t to the power of 3, yeah. And 6 divided by minus 2 is minus 3, yeah. So get that. Go on. F. So that's 1 over 2t minus 1, yeah. Which I can write as 2t negative 1. It's power of negative 1, yeah. Because 1 over, yeah. Safe. So what you want to do is you want to differentiate this first, yeah. So dx over dt. That's going to be bring negative 1 down. Differentiate the inside, so that's going to be 2, so bring 2 outside, and then 2t negative 1, and then take away 1 from the power, that's negative 2, yeah? That's going to be equal to negative 2 over 2t negative 1 squared, yeah? Because negative 2 times that is just negative 2 times, and then obviously on the bottom there, yeah? Calm. Now we've got y is equal to t squared, yeah? Over 2t negative 1. I'm going to have to do this using quotient rule, so u is equal to t squared. So find du over dt. So that's going to be 2t. Then this one here, so v is equal to 2t minus 1 here, and then again find dv over dt. So we get 2. Now obviously do v, so we're gonna find dy over dt here. So we're gonna need to do this times this here. So that's gonna be 2t negative 1, open bracket 2t minus 2t squared here. So this times this here. All of that over 2t negative 1 squared here. So effectively what we're doing is differentiating y here. Cool. 2t times 1 here is going to be negative 2t. And then 2t times 2t is 4t squared. And then 4t squared minus 2t is going to be 2t here. So it's going to be 2t squared in the end here. Minus 2t. All of that over 2t minus 1 squared here. Alright, save. So therefore dy over dx here is going to be this one dy, yeah, so 2t squared minus 2t over 2t negative 1 squared here divided by the dx over dt, which is negative 2 over 2t minus 1 squared here. So it's that cancels with that. Now we just get negative 2t squared minus 2t over 2 here. Obviously this you can simplify that to become 2 cancels, so you get negative t squared plus t, negative because you expand it into here, and then here this becomes plus, it's divided by 2. And now because of that we can take out t, so we're left with just t, and I can swap these around, so t minus t squared instead of the other way around, so it becomes 1 minus t. Yeah. Alright, well, g. X equals to 2t over 1 plus t squared here. So again, quotient rule here, so u is equal to 2t. V is equal to 1 plus t squared. Alright, cool. So du over dt here is going to be 2. dv over dt is going to be 2t. And obviously, therefore, dx over dt here is going to be that times that. So we got 2 open bracket, 1 plus t squared. Take away that times that. So that's going to be 4t squared. All of that over v squared, which is 1 plus t. So 1 plus t squared squared, yeah. Alright, calm. Save. Now what I can say here is that 2 times 1 is 2. 2 times t squared is 2t squared. 2t squared minus 4t squared will be negative 2t squared here. So it'll be 2 minus 2t squared. But I can take out the 2 here. So it becomes just 1 minus t squared here. Alright, save. All of that over this here. 1 plus t squared squared. Always the shit on the bottom doesn't really matter because it's going to get cancelled anyway, bro. So it doesn't really matter too much here. And then obviously y is, from the question, y is 1 minus t squared over 1 plus t squared, yeah. So again, bro, quotient rule as well. U equals 1 minus t squared. So therefore, du over dt is going to be negative 2t. And obviously, v is equal to 1 plus t squared here. So therefore, dv over dt is going to be 2t. So now what you want to do, obviously, times this by this. So we get dy over dt is going to be minus 2t, open bracket, 1 plus t squared. Negative this times this, so negative 2t, open bracket, 1 minus t squared. All of that over v squared, so all of that over 1 plus t squared squared. So there you go. And now obviously tidy up the top. So basically negative 2 times t is going to make negative t, 2t cubed, yeah? And negative 2 times t here is going to make positive that, yeah? So they're going to cancel. And then minus 2t is 1, minus 2t is another 1. That's together, that's negative 4, yeah? So negative 4t over 1 plus t squared, yeah? Squared. Alright, save. So now find dy over dx here. So dy over dx is going to be dy over dx. So dy was minus 4t over 1 plus t squared. Dx was 2 open bracket 1 minus t squared over 1 plus t squared, yeah? So obviously that cancels with that. So you just get negative 4t over 2 open bracket 1 minus t squared, yeah? And obviously that's equal to negative 4t over 2 minus 2t squared, which obviously I can simplify that. And you get negative t over 1 minus t squared, and I can times in the negative 2t here. 2t over, and then when I times in the negative, this thing swaps around, so this becomes positive here and negative there, so it becomes t squared minus 1 here. Alright, save. Alright, h. So t squared et. So I'm gonna teach you a little trick for the product rule, yeah, just to save time, since, you know, when you get to these kind of questions, yeah, you're gonna have to be doing it pairs here, which is long, yeah. So what you can just do, yeah, just write t squared, yeah. Write et. Don't even write any like working out here. Just differentiate that 2t, differentiate that et. That's it, and then times this by this, this by this. That's it, bro. Yeah. So dx over dt is gonna be what, bro? Dx over dt, yeah, is gonna be e to the power of t squared plus e to the power 2t et. Yeah. Alright, come on. And then y differentiated, so dy over dt is just gonna be 2. So therefore, dy over dx here, which is going to be dy over dx, which is 2 over e to the power of t squared plus 2t et, which I can take e out of the bottom to make it just a little bit easier, a little bit nicer looking here. So that's going to be t squared plus 2t et. I, I, J, L, M, I, J, K, L, M, N, O. Still bears. I. So I is going to be 4 sine 3t. Y is going to be 3 cos 3t. Obviously differentiate x here, bro. So if you differentiate x, we're going to find dx over dt. That's going to be, bring the 3 outside. That's 12 sine, not even sine cos here. Differentiation of sine is cos here, so get cos 3t. And then obviously dy over dt is going to be same thing. So bring the 3 outside. That's going to be 9. And then cos differentiates into minus sine, so minus 9 sine 3t here. Then obviously again for dy over dx, you need to do dy over dx. So dy over dx, you need to do dy over dx. So do minus 9 sine 3t, that's dy over dx here. So over 12 cot 3t. 9 over 12 is going to be 3 over 4. So negative 3 over 4, and sine over cos is tan here. And safe for J. Jack Jones, yeah. X is equal to 2t, yeah. Sine t. Y equals 3 minus 4 cos t. And obviously what you want to do here is do the same thing here. So obviously find dx over dt here. So dx over dt is going to be what, bro? Bro, this is plus, not 2t here. It's plus here. So that's just going to be cos t. Nice and easy. Dy is going to be what, bro? It's just going to be minus 4 cos. Cos differentiates into minus sine. Minus minus going to cancel. So it's just going to be 4 sine t here. Alright, safe. Dy over dx, you can see is a tan situation here. So we got dy over dx going to be 4 sine over cos, so 4 sine t over cos t. Obviously, that's going to get you 4 tan t here. Alright, save. Alright, okay. X is equal to sec t. Y is equal to tan t. Find dx. Sec differentiates into sec tan. Tan differentiates into sec squared, so we get dy over dt is equal to sec squared t. And now obviously, yeah, bro, dy is gonna be what then? Dy over dx here is gonna be sec squared over that. So sec squared t over sec tan, because you do the y over the x. Obviously that cancels with that. So we just got sec over tan. Tan is sine over cos. Sec is 1 over cos. So therefore, we've got 1 over cos over sine over cos. So as you can see, cos and cos are going to cancel. You just get 1 over sine, which is equal to cosec t here. Alright, save. Alright, L here. X equal to 2t minus sine 2t here. Is that close? Alright, save. And then y is equal to sine os. No, y is equal to 1 minus cos 2t here. Alright, save. So then find dx over dt here. So dx over dt is going to be 2 minus cos 2 cos 2t here, because obviously sine is cos, bring out the 2. And then dy here is going to be cos differentiated is minus sine, negative is going to cancel, which we're going to get, bring out the 2 as well, so 2 sine 2t, and then just put it together in it. So so dy over dx here is going to be 2 sine 2t over 2 minus 2 cos 2t, which obviously I can cancel with the 2, so it becomes sine 2t over 1 minus 1 cos 2t. And obviously sine 2t, if you use double angle formula, that's going to be 2 sine t cos t. And again, double angle formula for cos 2 t, you want it to cancel with sine here, yeah? So what I can do is I can write this as 1 minus 2 sine squared, yeah? 2t. So that's what cos 2t is equal to, yeah? It's equal to this. So therefore, yeah, obviously that's going to be 2 sine t cos t over 1 minus 1, and then negative times inside becomes positive here, so 2 sine squared t. Then obviously that cancels with that, cancels with that, so you just get cos t over sine t. Obviously that's just cos. Save m. X equal to et minus 5, y is equal to ln t. Dx over dt is going to be what, bro? It's going to be e to the power c. Dy over dt is going to be 1 over t. Save. Therefore, dy over dx is going to be 1 over t divided by et. So obviously keep flip change. So obviously keep this, change it to a times, flip this to 1 over et. So it's going to be t et. Yeah. And x equal to ln t. Y is equal to t squared minus 64. Yeah, obviously here you want to do dx over dt, so dx over dt is equal to 1 over t. Dy over dt is going to be equal to 2t And now obviously do the same thing. So dy over dx is going to be 2t. So dy divided by 1 over t. And obviously that's going to be 2t squared. So obviously this is like t to the power minus 1. So 1 minus minus 1 is 2. So 2t squared here. Alright, save. Oh. X equal to e to the power of 2t plus 1. Y is equal to 2e to the power of t minus 1. So obviously find dx here. So dx over dt is going to be 2e to the power of 2t. And then dy over dy over dt is going to be 2et. And then now just obviously do dy over dx. So dy over dx equal to dy over dt. So 2e to the power of t over 2e2t. So 2 and 2 cancels. This is like et and this is like et squared, yeah? So if you do et over et squared, that will like cancel with that effectively. So you just get 1 over et, which is just equal to e minus t, yeah? So yeah. Alright, cool, yeah. Question 2a. So we've got x equal to 3 minus 2 sine t, yeah? And now with this, what you want to do is we'll differentiate, yeah? So differentiate that. Minus 2 sine t is going to differentiate into minus 2 cos t, yeah? Calm. And then y is equal to t cos t, yeah? Obviously, write this out quickly. So this is going to be product rule, yeah, to differentiate that. So just write t and write cos t. Then differentiate t, you get 1. Differentiate cos t, you get minus sine t. And then just do that times that, that times that. So dy over dt here is going to be dy over dt. It's going to be minus t sine t plus cos t here. Alright. And obviously to get dy over dx here, you're going to do dy over dx here. So therefore it's going to be minus t sine t plus cos t over negative 2 cos t here. And obviously here, minus t sine t divided by negative half here. Negative half is negative is gonna cancel here. It's just gonna make half t, and then sine over cos is tan. And then cos divided by cos is gonna be, so 1 cos divided by 2 cos here is gonna be negative half in it. So negative half here. Alright, calm. Now you want to put t is equal to pi over 3 here. So I mean equal to pi here. So if t is equal to pi, you need to find the x coordinate, y coordinate, and the gradient here, so you can form the equation. So the x coordinate is gonna be 3 minus 2 sine t, yeah? So 3 minus 2 sine pi, which is obviously going to be 3. I'm going to find the y coordinate, yeah? So y is equal to t cos, so pi cos pi, which is obviously going to be pi, negative pi, so and then obviously finally, dy over dx here is going to be, put here, so that's pi over 2, because it's t over 2, and then tan pi minus half. Obviously, tan pi is a math error in it. There's just nothing here, so you get negative half as answer. And so it's tangent here, so the same gradient, so you can write y is equal to minus 1 over 2x plus c here. Y is equal to minus pi. X equal to 3. Obviously, times that together, you get 3 over 2 minus pi is equal to negative 3 over 2. So obviously, therefore, minus pi plus 3 over 2 here is equal to c. So now obviously I can write out the full equation here. So y is equal to mx plus c. So y is equal to negative half x. Plus, obviously I can write, instead of minus pi plus 3 over 2, I can write as 3 over 2 minus pi here. So 3 over 2 minus pi. Save. B. So x equal to 9 minus t squared here. So therefore dx over dt is going to be minus 2t here. And then y is going to be equal to t squared plus 6t. So therefore d1 is going to be 2t plus 6 here. And obviously dy over dx is going to be dy over dt, yes, it's going to be 2t plus 6 here over negative 2t, yeah. And obviously that's going to cancel, that's going to make negative t plus 3 over t, yeah, because 2 is going to cancel. And then obviously now, you want to make t equal to 2, yeah, to find what x, y, everything is here. So x is going to be equal to 9 minus 2 squared, which is going to be 5. And y is going to be 2 squared, yeah, plus 6 times 2, yeah, 16, yeah. So just put t into these two equations here. Calm. And then you want to find the gradient here, which is this. So put t into there. So that's going to be 2, negative 2 plus 3 over 2. That's going to be negative 5 over 2. So that's the gradient. So therefore it's tangent again. So y is equal to negative 5 over 2, same gradient plus c. And then y is obviously going to be 16. Negative 5 over 2, open bracket 5 plus c. Then obviously, yeah. So times the 5 there, bring it to the other side, you're going to get 57 over 2 is equal to c, yeah. So therefore I can write that out. I can write y is equal to minus 5 over 2x plus 57 over 2. And then times everything through by 2, yeah, you get 2y is equal to minus 5x plus 57. And obviously add the 5x to the other side, so you get 2y plus 5x is equal to 57, yeah. Alright, cool. Alright, question 3a, yeah. So we got x equal to et, yeah, and then we got y is equal to et plus e minus t. Now what you want to do here is you want to differentiate both of them, yeah? So differentiate dx here, so dx over dt here is going to be et. Then differentiate dy here, so dy over dt is going to be et. And then bring the negative down, so negative e, and then stays e minus t, yeah? Alright, save. So therefore, yeah, dy over dx here is going to be y over that, yeah? So et minus e minus t over et, yeah? So obviously et cancels with et, yeah, we're going to get 1, yeah? And then negative e minus t cancels with et, yeah? Minus 1, take away 1 is going to be negative 2, so e minus 2t, yeah? So minus t minus t, yeah, is going to be negative 2t, yeah? Alright. So now we're looking at t equals 0, yeah? So when t equals 0, yeah, which is the point that we want, yeah? Find dy over dx here. Dy over dx is going to be, put a 0 into here, so 1 minus e to the power minus 2, 0. You'll get 1 minus 1, yeah, because equal to 0, yeah? And then find, and calm, because it's a tangent, yeah, to this curve, it's going to be parallel to the y-axis, yeah? So, therefore, yeah, we just need to find, because the gradient is 0, yeah, it's going to be just the equation of x is equal to something, yeah? So x is equal to whatever the point is, so t is 0. The equation for x is e to the power of t, so e to the power of 0, so that's 1, yeah? So the equation of the tangent is x equals 1, yeah? Alright, part B. We've got x equal to 1 minus cos 2t. We've got y equals sine 2t here. Find dx over dt. That's going to be 2 sine, so differentiate cos, you get minus sine, minus minus cancels here, so 2 sine 2t. And differentiate y, you're going to get 2 cos 2t here. Alright, save. Now obviously t is equal to pi over 6 in the question here, so therefore I need to put pi over 6 into here, yeah? So to do that, I'm going to do dy over dx here. It's going to equal to dy over dx, so 2 cos 2y over 2 sine 2y. Obviously that's going to be 2 cot 2y. I don't know why I'm saying y, it's t, yeah? which is equal to 1 over 2 actually cancels, yeah, so it's calm. Which is equal to 1 over tan 2t, yeah, because cot is equal to 1 over tan, yeah, so it's 1 over tan 2t. And now you want to substitute into there pi over 6 here, because that's t, so 1 over tan times 2 times pi over 6 here. And that's going to get you 1 over root 3, yeah, so that's the gradient. That's the gradient. So that's the gradient, yeah, but we're looking at a normal, yeah? So normal is negative reciprocal. So do 1 over that as root 3 and then negative, yeah? So the gradient is negative root 3. Now you need to find x and y coordinate to form the tangent equation. So the x coordinate is going to be 1 minus cos 2 times pi over 6 here, which is going to be half. And the y is sine 2t, so it's going to be y is equal to sine 2 times pi over 6 here, which is going to be root 3 over 2. Alright, calm. Now I can write y is equal to mx plus c, yeah? So y is equal to minus root 3x plus c, yeah? So y is equal to root 3 over 2 minus root 3, and then x is a half here, plus c. Obviously, times the half there, bring it to the other side, you're going to get c is equal to root 3. So the final equation here is just y is equal to minus root 3x plus root 3. And then to put in the form that the book wants here, you can add that to the other side, so you get y plus root 3x equals root 3, yeah? Alright, question 4, yeah? Got x equal to t over 1 minus t. Then we got y is equal to t squared here over 1 minus t. Alright, safe. So obviously, yeah, quotient rule situation. So let's look at this one first here. So obviously, we got t as u, and we got 1 minus t as v, yeah? And obviously, differentiate both of these. T differentiated is 1, this differentiated is negative 1. And now just do quotient rule. I don't need to write a dy, all of that. What you do is just this times this here, that's 1 minus t. Yeah, and then this time this, yeah, that's a minus t, but it's negative, so it's plus t over this squared, yeah, which is 1 minus t squared. Obviously, that's equal to dx over dt, yeah. Now you do the same for y. By the way, minus t plus t is going to be 1 here, so just 1 over 1 plus t squared here. 1 minus t squared. Safe. Do the same for y here. So y is going to be dy over dt here. So again, right, so u is going to be t squared, and then v is going to be 1 minus t. Differentiate that, you get 2t. Differentiate that, you get minus 1 here. And so that times that is going to be 2t open bracket 1 minus t. And then negative 1 times that is going to be positive, so positive t squared. All of that over 1 minus t squared here. Save. And obviously 2t, listen, 2t times 1 is going to be 2t, yeah? 2t times minus t is going to be minus 2t squared. Plus t squared is going to be negative t squared, so it's going to be 2t, yeah? Negative t squared over 1 minus t squared. Alright. So that's the dx, dy over dt, yeah? Alright, save. So dy over dx here is going to be this divided by this here. So since this is the same on the bottom, you can just write the top divided by the top here, yeah? So 2t minus t squared divided by 1, yeah? Because this will cancel with that, yeah? Alright, calm. So that's 2t minus t squared, yeah? So that's the gradient, yeah? So I need to find the gradient at a certain point. Alright? So now we need to find what t is when the gradient is equal to 0. So at the stationary point, t is 0, yeah? So obviously factorize that. You get t open bracket 2 minus t is equal to 0. So therefore, obviously t is equal to 0. Because opposite of the bracket, yeah? So if there's a t on its own outside, that means that t equals 0. And here, opposite of the bracket, yeah? So t is equal to 2, yeah? Safe, bro. So basically, when t equals 0, find x and y. X is going to be 0 divided by whatever, which is 0, and y is going to be 0 divided by whatever, which is also 0, yeah? So that's going to be x equals 0 and y equals 0. And then when t is equal to negative 2, sorry, yeah, x is going to be equal to 2 divided by 1 minus 2. 1 minus 2 is negative 1, so 2 divided by negative 1 is negative 2, so x is going to be negative 2. Now y is going to be, again, so put 2 into this one. So 2 squared here is going to be 4. And then 1 minus 2 is minus that, so that's -4, yeah? Alright, cool. So the stationary points here is 0, 0, and -2, -4. Alright, save. Alright, question 5a. X equal to e power of 2t, yeah? Y is equal to et -1, yeah? Alright. So obviously find dx over dt. So bring 2 down. So dx over dt is going to be 2e2t. dy over dt is going to be et, yeah? And now obviously find dy over dx here. So dy over dx is going to be that over that. So et over 2e2t. Obviously, that's going to cancel with one of these. So that becomes 1 over 2 et. And now you need to make t equal to ln2 because that's what it says in the question. So t equals ln2. And so therefore, if it's ln2, then the gradient is going to be 1 over 2 e to the power of ln2. Obviously, e ln cancels, so it's just 2 squared, which is just 4. So 1 over 4. 2 squared, 2 times 2, yeah? Alright, calm. And then x is going to be e to the power of 2 ln2. I'll bring that up here, that becomes e to the power of 2, ln2 squared. So obviously that cancels, you get 2 squared, which is 4. So x is 4, y is equal to e ln2 -1. Obviously that's 2 minus 1, because that cancels. So 2 minus 1 is equal to 1. So therefore you get all of these things here. So now y is equal to, the gradient is 1 over 4x plus c. X obviously 4, y is 1, so 1 is equal to 1 over 4 times 4 plus c. And now obviously 4 times 1 over 4 is 1, so 1 is equal to 1 plus c. Obviously c is equal to 0. Therefore y is equal to 1 over 4, which is the gradient x here. Alright. Part V, yeah. B is saying that find when dy over dx equal to 0, yeah, find the stationary points here. So obviously make that equal to 0. So the gradient was 1 over 2 e to the power of t, yeah. So make that equal to 0. Therefore, times half up there, and I can rewrite, so 1 over et is equal to 0. And I can rewrite 1 over et as e to minus t, yeah, equals 0. Obviously here we've got no solutions, we can't solve that, we can't do ln on both sides here, we can't really do anything, so therefore we can't solve that. So there's no solution, so just right there is no solutions here, so therefore no stationary points here. Well, alright, question 6. X equal to t squared here minus 3t minus 4 over t, yeah? So therefore I can simplify that to t squared over t is just t. Yeah, minus 3t over t is minus 3, and then minus 4 over t is minus 4. And I can write that as minus 4t to the power of minus 1, yeah? Alright, cool. Cool. It says that y is equal to 2t. So now I just got to differentiate, yeah? So dx over dt is going to be differentiate t, get 1, differentiate -3, get nothing, differentiate that, bring the -1 down, that's going to make positive 4t, and then take away 1 for power, that's -2. Obviously, that's the same as 1 plus 4 over t squared here, because t -2 is like 1 over t squared, times 4 is going to be 4 over t squared. Now, obviously, dy over dx here, dy over dt is going to be 2, so just differentiate that, you get 2. So now, obviously, you want to find dy over dx, so dy over dx is going to be y over x, so y is 2, x is that, so 2 over all of that, so 1 plus 4 over t squared. You already know what you're going to do here, bro. You're going to times everything by t squared, so times t squared here, times t squared here, and then that cancels with t squared, so it's just going to become that. So now you got this here, calm, and this is parallel to y equals x plus 5. So if it's parallel to y equals x plus 5, it means that the gradient m is going to be 1, yeah? Or dy over dx other times is going to be 1. So if dy over dx is 1, yeah, it means I can find certain situations. I can times that up there, and I can get 2t squared, yeah, is equal to t squared plus 4, yeah. And hence take away t squared from the right hand side to the left hand side. That's going to be t squared here is equal to 4. So therefore t is going to be equal to plus minus 2 here. Because you square root that, so plus minus 2. It says that t in the question has to be bigger than 0. Therefore t is equal to 2 here. Alright, cool. So now find x and y. So to find x, you just substitute into the top x equation. So I'll put 2 into that. So 2 squared minus 3 open bracket 2 minus 4 over 2. And that's going to be negative 3. And then same thing with y, put it into the y equation. So it's going to be y equals 2 open bracket 2 because it was 2t. So now equals 4. Yeah, so now I've got all the information that I need. I can form the equation. So y is going to be equal to, gradient was 1, so it should x plus c. Y was 4, x is minus 3. So therefore bring negative 3 to the other side, you get 7 is equal to c. So therefore the equation is y is equal to x plus 7 here. Yeah? Alright, save question 7a here. X is equal to 2 sine squared t here. We've got y is equal to 2 cot t. Obviously, the x is going to cancel, differentiate into what, bro? It's going to be, again, like take squared out, yeah? So take 2 down, yeah? That's going to make 4, yeah? And then, take away 1 from the power, so 4 sine t. Then differentiate sine, you're going to get cos, yeah? So cos t. Then dy over dt is going to be negative 2 cosec squared t, yeah? So therefore dy over dx is going to be negative 2 cosec squared here over 4 sine t cos t here. Which if you think about here is going to be 2 and 4 is going to cancel negative 1 over 2 here. 1 over cos is sec. And then cosec squared divided by another sine. Cosec is already 1 over sine. So 1 over sine squared divided by another sine is going to be cosec cube here. 1 over sine cube. Alright, calm. And then part B here. Part B is saying that t is equal to pi over 6 here. So when t is equal to pi over 6 here, you need to put that into x here. So x equal to 2 sine squared pi over 6. That's going to be 1 over 2. And then y is going to be 2 cot pi over 6 here. Which is going to be 2 root 3. And I need to find dy over dx. Dy over dx here, at this point, is going to be negative half sec of pi over 6. Cosec cube here of pi over 6. Which is going to be negative 8 root 3 over 3. So we're looking at a tangent here, bro. So it's going to be y is equal to minus 8 root 3 over 3 here. X plus c here. And obviously we know what x is, we know what y is. Y is just going to be 2 root 3. And x is just going to be what we found earlier, yeah, that's a 1 over 2. So 1 over 2 here plus c. And obviously you bring c to the other side, so times half in and then bring that there. And you're going to get 10 root 3 over 2 over 3 is going to be c here. So therefore y is going to be equal to minus 8 root 3 over 3x plus c here, which is 10 root 3 over 3. And then obviously times everything by 3. So you get 3y is equal to negative 8 root 3x plus 10 root 3. And then divide everything by root 3, yeah? 3 divided by root 3 is going to be root 3. So we get root 3y is equal to negative 8x plus 10, yeah? And finally, they want it in a certain form, so bring everything to the left-hand side. So that's going to be root 3y plus 8x minus 10 equals 0, yeah? Alright, calm. Question 8. Question 8a says that x is equal to 4 sine t. It says that y is equal to 2 cosec t, yeah? Alright, calm. So, yeah. It also says that x is equal to 2 root 3, yeah? So hence, if x equal to 2 root 3, that means that 4 sine t, which is x here, is going to be equal to 2 root 3 here. So I can find what t is now, yeah? So I can say that sine t is going to be equal to 2 root 3 over 4, yeah? Which is obviously equal to root 3 over 2. And so sine inverse that you get t. So t is going to be pi over 3, yeah? And then to find the second solution for sine, yeah, you need to do some bullshit in it, bro. You need to do pi minus the first answer, yeah? So that's going to be 2 pi over 3, yeah? So those are the two solutions in the range here. And so now what you want to do is obviously find the coordinates for whatever you need to do here, yeah? So 2 t is equal to pi over 3, yeah? So therefore put that into y. So y is equal to 2 cosec 2 times pi over 3. And that's going to get you 4 root 3 over 3, yeah? And so therefore t is equal to pi over 3 at a, yeah? Because at the point a was 2 root 3 and 4 4 root 3 over 3, yeah? You get it? Alright, cool. Now part B, yeah. So for part B, we got x equal to 4 sine t, yeah. So therefore dx over dt, yeah, is gonna be standard, bro. That's gonna be 4 cos t, yeah. And obviously now we got y is equal to 2 cosec 2t. So obviously differentiate that. So you find dy over dt times the 2 outside. It's gonna make 4, yeah. It's gonna be negative cosec differentiates into negative cosec cot, yeah. So cosec 2t cot 2t, yeah. And obviously find dy over dx here. dy over dx here is going to be dy divided by dx. So it's going to be negative 4 cosec 2t cot 2t. All of that over 4 cot t. 4 cos t, yeah. 4 cancels with 4, yeah. And then you're just going to get left with cosec 2t cot 2t over cos 2t, yeah. Over cos t, yeah. Alright. Yeah. This question has like a little bit of a mistake, I'm pretty sure, yeah. It's got it says something in the book here, but the book is wrong in it. It says prove that's equal to this here, but it's wrong in it. So alright, calm. So what you want to do here, yeah, is obviously find dy over dx here at the point that t is equal to pi over 3, yeah. So find at the point where it's equal to pi over 3, so we get minus cosec, should be negative here, yeah. 2 times pi over 3, and then cot 2 times pi over 3. Over cos pi over 3, yeah. And if you do that in your calculator, yeah, it's going to give you 4 over 3. We're looking at the normal here, so the normal is going to be negative reciprocal, yeah. So the actual gradient is going to be negative flipped here, so 3 over 4, yeah. So therefore, yeah, y is going to be negative 3 over 4, x plus c. We know what y is already from part A or whatever, so 4 root 3 over 3. We know that we know what x is as well, it's going to be 2 root 3, yeah. So therefore, I can say that. Now you need to find c, so times the n, bring it to the other side, you're going to get 17 root 3 over 6 is equal to c, yeah. So therefore, I can write the y equation, yeah. So y is going to be equal to negative 3 over 4, which is the gradient x, plus what we just found as c, yeah, which is 17 root 3 over 6. And now, times everything by 12, so you're going to get 12y is equal to minus 9x plus 34 root 3. And then bring that all to one side here, so bring that to the left hand side, so it's going to be 12y plus 9x minus 34 root 3, yeah, equals 0. And that's the answer, yeah. I know when the question is different in the book here, but that's just because it's wrong, bro, yeah. Solution bank has the same as this here. Alright, calm. Question 9, yeah. So x is equal to t squared plus t. Y is going to be equal to t squared minus 10t plus 5. And now what you want to do here is basically you want to just like differentiate it. So dx over dt here is going to be 2t plus 1 here, and then dy over dt is going to be 2t minus 10. So therefore dy over dx, you can get that straight away. Dy over dx is going to be 2t negative 10 over 2t plus 1 here. Save. And it tells us that dy over dx at the point is equal to 2 here, because it tells us gradient is 2 here. So therefore, I can times this up here. So I get 2t negative 10 is equal to 4t here plus 2. I'm timesing that up there, yeah, so by 2. And I can find what t is now. Bring 4t to that side, you get negative 2t. And then bring 10 to that side, you get 12 here. So therefore, t is equal to negative 6. So now I can find what the x and y coordinate is here. So x coordinate is going to be negative 6 squared here, because it was t squared minus t. So negative 6 squared minus 6 here, that's going to be 30. And then y is going to be negative 6 squared here, take away 10, negative 6 plus 5 plus t here. So that's why it's negative 6. Alright, come. Plus 5. That's going to get 101 here. So you're going to get the coordinate is basically 30 and 101. Alright. Part B here. Part B, we obviously know the gradient is 2. So therefore we got y equals 2x plus c. We know the y coordinate now is 101. We know the x coordinate was 30. So we can find c easily, bro. Nice, easy question here. C is obviously equal to 41 times 2 there. Bring that side, 60 that side, you get 41 here. And now obviously that means that y is equal to 2x plus 41. Save part C. So y is obviously equal to t squared here, minus 10t plus 5 here. That's what we established. And obviously we know that y is also equal to 2x plus 41, as we just got from the equation. So what I can do here is I can replace the y equation. So to see if it intersects again, I can replace this y equation with what x is equal to here. So x is actually equal to t squared plus t here from earlier, plus 41 here. And so what I can do now is I can make the two y's equal to each other to see if they intersect here. So t squared minus 10t plus 5 is going to be equal to 2 open bracket t squared plus t plus 41 here. Expand that and bring it to one side. So combine it, say equal to 0. So t squared minus 10t plus 5 is going to be equal to 2t squared here plus 2t plus 41. Bring t squared to that side. We're going to get t squared here. Minus 10t, bring it to that side, going to become plus 12t. And then negative 5, bring it there, that's going to become plus 36. All of that's equal to 0, yeah? Now, obviously, it says find out how many solutions here, or if it intersects or whatever, yeah? So you need to do discriminant here. So discriminant is equal to b squared minus 4ac. So b here is 12, so that's going to be 12 squared here, minus 4, a is 1, so 1, and c is 36. So this is a here, got 1 there if you think about it, and this is c. Alright, calm. If you put that in your calculator, you'll get 0, yeah? So that means that there's only one, hence only intersects once, yeah? Just write it out, yeah? So that means like it's the point that we found the intersection, that's it, that's the final intersection, yeah, that's it. Alright, calm. Question 10, yeah? So 10a, we've got x is equal to 2 sine t. We've got y is equal to root 2 cos 2t, yeah? Alright, calm. So dx over dt here is going to be 2 cos t. And dy over dt is going to be negative 2 times the 2 outside. That's going to be negative 2 root 2, yeah? Sine 2t. And so therefore dy over dx here is going to be dy divided by dx here. So negative 2 root 2 sine 2t over 2 cos t, yeah? And you can already clock straight away, yeah? That I'm going to cancel 2 there. And then I'm gonna expand sine 2t using double angle formula into 2 sine cos. So times another 2 out there is going to be minus 2 root 2 sine 2 sine t cos t, yeah? over cos t, and obviously that's to make it the same here, so cos cancel with cos, so we just get negative 2 root 2 sine t, yeah? By the way, if you're confused about why the 2 is still out here, it's because it cancelled the 2 here, and then because sine 2t is equal to 2 sine cos, you times the 2 out again, you get it. Alright, calm. Question B, yeah? Alright, so t is equal to pi over 3, and so therefore x is equal to 2 sine pi over 3, which is going to be equal to root 3. And then find the y coordinate, yeah? The y coordinate is going to be root 2 cos 2 times pi over 3, which is going to be negative root 2 over 2. Alright. Safe, and then find dy over dx here. So dy over dx is going to be negative 2 root 2 sine pi over 3. So that's just using the equation we just found in part A. That's going to give us negative root 6. So I'm pretty sure this is a normal. So a normal is going to be negative reciprocal. So the real gradient we're going to be looking at is 1 over that. And then positive version here, because negative is positive here. So now we've got y equals 1 over root 6 x plus c here. We know what y is. Y is just negative root 2 over 2. And we know what x is. X is, we just found it now, as root 3. So now you just need to find c. That times that, yeah, is going to become root 3 times 1 over root 6 here. You can put that in the calculator. It's going to be 1 over root 2 here. And so what I can say is that c can be root minus root 2 over 2, negative 1 over root 2 here. Which is honestly just equal to negative root 2, if you put that in your calculator. So hence the final equation is going to be y is equal to 1 over root 6 negative root 2, yeah? Now times everything by root 6 to get root 6y is equal to 1x, or yeah, x here, yeah? Minus 2 root 3, yeah, if you times that by root 6, yeah? And then they want it on one side as well, like say to 0, so just 0 here, bring 6y to the other side, so you get x negative 2 root 3 minus root 6y here. That's the answer. Alright, part C. Alright, so we're going to use the equation here that we just discovered here. So that's 0 equals x minus 2 root 3 minus root 6y. And we're going to substitute what x is here. X in the question was 2 sine t, negative 2 root 3, and then negative root 6. And then y in the question was root 2 cos 2t, yeah? Alright, safe. Safe, bro. Times root 6 by root 2, we're going to get 0 is equal to 2 sine t. I'm just going to put this here, so negative root 3 cos 2t, negative root 3. So what I did actually, bro, is my bad. What I did here is I divided by 2, yeah? So get rid of that, yeah? So what I did is I divide by 2, divide that by 2, you get sine t. Divide this by 2, you get minus root 3. Divide root 6 times root 2, divide by 2 is minus root 3, yeah? Alright, calm. Now what do we do? That's the question, yeah, that everybody's been asking me. So they're about to find out. If they just, bear with a little bit, yeah, they'll find out. They'll find out. But of course, people they don't wanna, find out. You know what I'm saying? They want it to come tailor-made. You get me? So obviously what you need to do here is obviously change cos 2t into 1 minus 2 sine squared, because there's a sine here, so you can see we're gonna form a quadratic here. So sine t minus root 3, open bracket 1 minus 2 sine squared t. So obviously that's what the double angle formula for cos 2t in terms of sine. And now obviously just expand that, bro. So 0 is going to be equal to minus root 3 minus another root 3 is going to be minus 2 root 3. Negative times negative 2 is going to make positive 2 root 3 sine squared here. And then you got the sine t from here. Alright, calm. Now you can use your calculator, just imagine sine is x, so just write 2 root 3 x plus x minus 2 root 3. And you're going to find that the brackets are going to be 2 sine t minus root 3, so it would have been root 3 over 2, the original thing. And then here's going to be root 3 sine t plus 2, yeah. Alright, cool. Therefore, sine t is going to be equal to root 3 over 2, yeah. And sine t is going to be equal to negative 2 over root 3. Obviously, negative 2 over root 3 is, you can't sine inverse that because it's bigger than 1. So I can only use this solution, bro. Alright, cool. And so therefore, sine inverse root 3 over 2, you're going to get t is equal to pi over 3. And then do pi minus pi over 3 to get the second solution. That's going to be 2 pi over 3. So for t equals 2 pi over 3, x is going to, because we already did pi over 3, substitute that in part A or B or whatever. So 2 sine 2 pi over 3. That's going to equal root 3. And then obviously y is equal to square root 2 cos 2 times pi over 2 pi over 3. That's also going to equal negative 2 over 2. Negative root 2 over 2. So therefore it's the point A, yeah? So same point as A. So this is the same point as A even with this solution, so therefore it's not going to intersect again, yeah? You get it. Alright, calm. Question 11, yeah? X is equal to cos t, and y is equal to half sine 2t, yeah? So therefore dx over dt here is going to be negative sine t, and dy over dt is going to be, bring the 2 there, that's going to be 2 times half is just, normal standard, bro. That's going to be cos 2t, yeah? Alright, calm. And then obviously, dy over dx here is going to be cos over sine, yeah? So cos 2t over minus sine t. That's the answer for the differentiation here. Then part B says t is equal to pi over 6. So find what x is at that point. So that's going to be cos of pi over 6, which is going to be root 3 over 2. And then find what y is. So y is going to be 1 over 2 sine 2 times pi over 6 because 2t. That's going to get you square root 3 over 4. Allegedly. Alright, calm. And then obviously also find what dy over dx is at that point, yeah? So dy over dx is going to be negative cos 2 times pi over 6 over sine pi over 6. So that's going to be negative 1, yeah? Alright, cool. So therefore the equation is a tangent, yeah? So it's going to be same gradient as that one, so negative x plus c. We know y, we just found it's root 3 over 4. We know x as well is root 3 over 2, and so plus c. So therefore c can be found, bro. Just bring that to the other side, and you get c is equal to 3 root. It either says root 2 or root 3. Root 3 over 4, yeah? So therefore the equation to the tangent whatever is y is equal to negative x plus 3 root 3 over 4, yeah? Alright, part C, final part. Alright, cool. So therefore, so dy over dx here was equal to minus cos 2t over sine t, yeah? And now it's telling you that the gradient is equal to negative 1, yeah? Because it's saying that's same gradient as whatever line, and that line has a gradient of negative 1, yeah? So you do that times sine t up there. So you're going to get negative cos 2t is equal to sine t, negative sine t as well, but then the negative cancels, so you just get that and that. Obviously, you know what to do here, bro. We're going to need sine on both sides, so change this cos 2t is double angle formula. 1 minus 2 sine squared is double angle formula, bro, for cos 2t. It's equal to sine t. And then add that to that side. That's going to be 0 is equal to 2 sine squared t plus sine t negative 1, yeah? And now, obviously, 0 is going to be equal to factorize this. So again, put in your calculator or whatever. We're going to get 2 sine t negative 1 and sine t plus 1. So therefore, sine t is equal to half or negative 1. Okay, cool. So obviously, sine inverse half, you're going to get t is equal to pi over 6. And then second solution, do pi minus that, which is 5 pi over 6. And then sine inverse of this one, yeah, you're going to get some negative number, I think. And because the range is between 0 and pi, you're going to need to add, I think, 2 pi to it, or something like that. You should get 3, you're going to get 3 pi over 2 as the answer. So just add 2 pi to it either, or, no, let me just do it right now. Sine negative 1 is obviously going to be, yeah, pi over 2. Yeah, and just add 2 pi to it, yeah? And then you get an answer that's in range between 0 and 2 pi. If you do pi minus the first solution, it's going to be too big, yeah? So I'm going to be in range. Alright, calm. So now you need to find for, it's already found for pi over 6 in the first part, so find the equation for t equals pi over, 5 pi over 6. So x is going to be cos 5 pi over 6. That's going to be root 3 over 2 negative. And then y is going to be half sine 2 times 5 pi over 6. So it's going to be negative root 3 over 4. Calm. And obviously y is equal to therefore negative x plus c, because we know that negative 1 is a gradient. It's the same gradient for all of them, for all these points. So I can say negative root 3 over 4 is y. Negative, obviously, root 3 over 2 is x. G. So those things. Obviously, this is negative here as well, so it's double negative here. Don't make that mistake. So that's positive, so it's going to be negative root 3 over 4. Take away that root 3 over 2, you're going to equal c, which is going to be negative 3 root 3 over 4. So it's just the same solution as part A. So y is going to be equal to y is going to be equal to negative x, negative 3 root 3 over 4, like in part A or B or whatever. Obviously, it's the same. You're doing pi minus that solution, so it should be the same. And then, yeah. And then also find for t is equal to 3 pi over 2, yeah? So t equals 3 pi over 2. So for t equals 3 pi over 2, yeah, x is going to be equal to 0 and y is going to be equal to 0. Just put it into x and y, you get 0, 0. Yeah, put cos of 3 pi over 2 and put half sine 2 times 3 pi over 2. We get 0, 0, and so therefore the equation is just y is equal to negative x, yeah, because c is going to be 0. So therefore, yeah, that's it, bro. Just y equals negative x. You get it. So yeah, man, that's the end, bro. That's how it is, man. So obviously negative 1 was a gradient, yeah. Alright, say this.